In this video, we will be observing the quality of our forks by seeing how it reacts under extreme temperatures, as well as showing its durability and strength, and whether or not the final product has conformed to the original design. Before anything, we'll be weighing a chunk of chicken because this is what we will use to test the strength of our product. And we can see that the chicken, it weighs roughly 0.5 grams. And we also have noodles on the ready at the side. We start our experiment by testing our product in really hot water, which is a boiling point at a temperature of 100 degrees Celsius. First, we test the chicken with a plastic fork to see that it can be lifted up. Next, we lift it with our product and see that it can do so as well. And now we submerge our fork in the hot water and we wait to see what will happen. For this experiment, we'll be testing our fork every 2 minutes interval after the 1 minute mark. We can observe after the 1 minute that the spoon can still pierce a chunk of chicken and twist and lift the noodles. So next up, we will set our timer to 2 minutes. Now that we reach a 3-minute mark, we observe that the fork is having difficulty piercing the chicken, but no problem lifting the noodles. We observe the reason to be because the neck of the fork seemed to become weaker because of the heat and wetness coming from the hot water. Moving on to the 5-minute mark, we tested it again to see until what the fork is capable of and found that it can no longer pierce the chicken because the teeth became dull because of the heat and wetness, and the neck also got weaker, but it still has no problem lifting the noodles. From this, we recommend, if using the fork in boiling water, not to continuously submerge it, but take it out if not in use to have a longer lifespan of the fork. Now we tested it out in cold water and measured the temperature using digital thermometer, and based on research, if the thermometer says low, the temperature is below 26 degrees Celsius. Again, we did the same procedure as the last experiment, comparing the Areca fork to plastic and still using the same 2-minute interval. After the 1 minute, as seen, the fork has no problem piercing the chicken, so we move on to the 3-minute mark. It still has the same results. So now, we move on to the 5-minute. The fork stayed the same, retaining its shape and form. So now, when we move on to the 7-minute, we came up to the fork still held steady and no significant changes were observed. So with the results obtained, the researchers concluded that when using the fork for cold temperatures, it still retains its shape and form and still performs well, but we still recommend to not continuously soak the fork in water. Since there is a great difference of reaction between hot and cold temperatures, the researchers wanted to know what will happen when reacting to lukewarm temperature of 37.9 degrees. And again, the same procedures are used, and after the 1 minute mark, the fork still performs well, so on to the 3-minute mark. We observed that still not much difference was found except that you can feel the handle softness. Now with the 5 minutes, we observed that again the fork is still able to pierce the chicken and lift the noodles, but slight torsional stress was found in the handle since when twisting the noodles it slightly twists as well. With 7 minutes in, we found that there is no problem in terms of performance for the fork, but we found some changes in its shape and form, one being the head of the fork bending outwards. We tested towards 9 minutes up, and still, we found that it is able to perform well, and the shape has slowly bended outward for the head. Now, since there is not much difference in terms of results, we used up our interval up to 5 minutes to see how long the fork can last in lukewarm water, and found that again the fork can pierce through the chicken and lift the noodles. But its shape, however, has changed, whereas the head of the fork bended outwards and the handle seems more soft. Thus, the researchers recommend again when using the fork, even in lukewarm water, to not submerge it for too long. But it can last for about 15 minutes if submerged continuously. Next part of the video is a measuring of the product to see whether or not it has conformed to the original design. We test our products by the curvature, handle length and width, head width, tooth space, and length. Now for the curvature, the original design was 15-degree radius and we got the same. For the handle length, the original design was 88.90, we got 90. Next, for its width, we got 9 centimeters when our original design was 8. For the head width, we only had a difference of 0.50. As for the tooth space, we got the same. And for its length, we got 15 when the original was 13.73. We only gave out one example on how we measured it to save time, but we will show the results from different types of areca. With the teeth only, we got 93.98% precision, and with its slots, we got 95.48%. So we conclude that pre-cutting the areca completely to the shape of the fork is better since the quality is better and not much production time is sacrificed. Thank you and God bless.